Okay, everybody, 2-minute warning. I figure we'll give people a couple more minutes to get that last cup of coffee, but we'll be starting in a couple of minutes. Okay. I think we're as ready as we're going to be. Welcome to DNS operations. If you don't mean to be in DNS operations, you might prefer to go back to sleep. But here we are at IETF 116. So we'll go through the chair slides first, and then we'll get into our regular agenda. Tim is not with us in person, but is out in the ether. Benno and I get to be here in real life and see all you lovely people. So we got Benno, Tim, and Suzanne. Warren, who is also not in the room, but is recovering from being ill, and we look forward to hearing from him. The usual things about chat rooms, minutes. Thanks, Paul Hoffman, for taking care of that for us. The note well, everybody has seen this. By Thursday, everybody has seen it multiple times. I hope you've read it at least once, because it does govern how your activities in the IETF are part of the process. Next. Code of conduct. This again should be very familiar and not a big challenge for folks at this, especially at this point in the week. Thank you for observing it. Next. A couple more meeting tips that the chairs were asked to make sure the room had heard. This session is being recorded. For in-person participants, make sure to sign into the session using MeetEcho from the data tracker agenda. Use MeetEcho to join the mic queue. It's especially appreciated if you can do that because that helps us manage between the virtual and physical queues. Keep your audio and video off if not using the on-site version. And please wear masks unless actively speaking on a microphone. Remote participants, we're glad you're here. Make sure your audio and video are off unless you're chairing or presenting during the session. Use of a headset is strongly recommended. Next. Yep. So our agenda, blue sheets, agenda, etc. We have a virtual blue sheet. If you signed into MeetEcho, you should be on it, but everybody should be signed into MeetEcho if only to be on the blue sheet. We've got updates of ongoing work. We've got a brief guest presentation on the GNU name system, current working group business for consideration for possible future adoption, and time permitting. Next. Yeah, I'll do. Structured error data for filtered DNS. That's one of our documents that we need an update on it. Implementation update, domain verification techniques. Next. Additionally, for consideration, compact denial of existence in DNSSEC, and consistency for CDS, CDNS key, and CSync as mandatory. Next. Okay. Generalized DNS notifications and DNS out of protocol signaling. Again, for consideration for possible future adoption, and time permitting DNSSEC extension using PKIC certificates. And Tim is going to do the slightly more detailed update. You ready, Tim?
Yes, I am.
Okay, terrific. You sounds
you
fine.
Can hear me?
Take it away.
So thanks, Suzanne, and thanks, Benno. Thanks all. So we have a bunch of document updates, and as you can see, since our last meeting, the DNSSEC BCP is now published, and thanks for Paul for putting the effort into that. We appreciate that. Sitting in the editor's queue is the catalog zones document, just sort of waiting for the editors to get to it. It's all in good shape, so that's pretty good. The next page, Suzanne, we do have several things sort of in a state. Did you do the next page? Sorry, there we go. I see it now. The Service B document, as you all remember, was sort of stuck in the editor's queue, waiting for the ENSI document. And this was sort of holding up a bunch of stuff. So Warren did his super magic stuff, process magic. And he brought it back to the working group. The authors removed those sections, and it's back in the process. And it's in IETF last call already, and it will end next week, it looks like. So thanks for everybody moving that along really quickly. The much shorter ENSI portion will most likely end up in the TLS working group because it's a very small document and it's probably more relevant there. And they can sort of have fun with that. So thanks all. Of course, the alt TLD document, which has kept Warren and Paul sort of busy. That's in the IETF last call as well. That goes another week until the 10th. Looks like things are good, but with that wrapping up, Christian is hoping this will help unstick the DNS draft, the GNS document that is in the ISE queue, and he's going to give a little short update about that right after this, and we think it shall. The 5933 biz is still in a holding pattern, and that's fine. Warren, if you need us to help you with anything, just let me know or let us know, and we can, put some time aside to do that. So we know it's sort of a weird state. We do have several documents in this post working group last call state. And I finally realized today, like, hey, I can put notes in the data tracker, though it shows up in a weird spot, and so that's kind of strange. But it's at least a start. So the first one is the avoid fragmentation. Thank you, Suzanne. There are some comments from the implementers on deployment guidance that was sent to the mailing list. So we attempted to summarize those comments in an organized fashion into an implementation appendix. And the authors published version 12 today, and there was some communication mix up on our part. It'd be good to get some reviews and good to get feedback from the working group, because there seem to be some strong opinions on what they will and will not do. And I'd like to hear what people sort of think about that. So that would be sort of super useful. Of course, the 8499 biz has finished up, and the Shepherd write-up will happen next week. That was promised to us, Mr. Benno. So thank you for that. The glue is not optional draft also finished up, and the Shepherd write-up is currently underway. I don't think we sent a note to the list, but please see the author's note to the mailing list regarding the sibling glue part. That is really relevant. And Schumann and Dwayne both made very good comments about that. So, and I think both of those are in pretty good shape. So then we sort of come up to the domain verification techniques, which actually Siobhan's sort of talking about here in a bit. And we felt that the working group last call had hit consensus, but there was a little bit of stickiness around around the token concept that seemed to be resolved, but there are some editorial clarifications. I see them in the GitHub repo that the authors want to sort of put together, and Siobhan's going to do a little sort of update on what's going on there. I think because it went from an informational to a BCP, a few people felt things had sort of changed along the way. So please, if people have comments during his talk, please speak up. Now, in the case of the DNSSEC validator requirements, we have some editorial comments that came in, most of them helping to clarify the language. And we're working with the authors and reviewers to get those addressed. And I think one of the authors who we've signed up to help work on that is in the room. And so we will work with you, Ed, to make sure those things get sort of sorted out. And mostly it's more clarification and sort of cleaning up the language. It does not seem to be normative type changes, but it will probably go back to the working group as it's been a little bit of time. Yes, we have several documents that are ready for working group last call based on our discussions with the authors and stuff. Zone version, DNS error reporting, and caching resolution failures. We really, we want to get a couple of these documents in working group last call moving along, not all of them, but just a couple before we start moving these. But we want to make sure we get good working group feedback to help us on these working group last call documents. So, and next page, we do have some more documents that are kind of being worked on. Oh, did we miss a page? Yep. The DNSSEC, Peter's DNSSEC bootstrapping. We've seen a bunch of nice sort of comments and edits from Peter. We want to sort of double check with him. We think it's pretty close, and we failed to sort of track him down. That was our fault. And as revalidation, the authors seem to have resolved all their outstanding to-dos. I think mostly removing text that seemed to be helpful. So thanks, Schumann. DNSSEC automation, we kept thinking it needs another author because it's sort of stuck, but we're waiting to sort of figure out what's going on there. Service B Dane has been quiet. And then on the agenda today is structured DNS error page. It's on there twice. So it seems to be a hot topic. People are pretty psyched to do stuff. There's a protocol update and then actually implementation stuff, which is always good times. So that's where things are. We do have a couple things that I know are on our adoption list, and we need to sort of sit down and sort that out. But we wanted to sort of clear up this log jam a little bit. So if folks have comments, throw them at us. I was hoping the notes I put in the data tracker people could see, but they're kind of hard to find. So I apologize for that. I think that's where we are on that. And then I believe, Christian, if you're there.
Yes, he's here. He's here.
Okay.
Thanks, Tim.
So thanks all. Yep.
Okay. Okay. Good. That's good, I guess. Thank you. Yeah, so I'm here to talk about the GNU name system. That's a document that's not part of this working group officially, but somewhat related, since it's the GNU name system, not the domain name system. Next. So as you all know, DNS censorship is widespread. DNS is part of the mass surveillance apparatus. And we also have injection attacks. The working group has, in the last decade, spent a lot of work on things like DNS over TLS, DNSSEC, and so on, as you all know, to defend against some of these attacks. But the GNU name system is another attempt to doing this with a more radical redesign. Next. The GNU name system is decentralized with secure memorable names. Just like DNS, you can use delegation to delegate resolution to another zone. For example, if you have, www example of dns.alt, looks like a DNS name, and you could have the whatever gns.alt. There's a zone example in there, and then that could delegate to subzone ww or to a record. In our configuration, you would then typically put for any zone the respective public key of the authority that would sign the records in that zone. And that's kind of how you start the resolution process, is by configuring for any kind of domain name that you want what the public key is supposed to be. Next. So the key features of DNS is, first of all, it's compatible. GNS is compatible with DNS. So you could use it as a drop-in replacement and resolve DNS names using GNS. The key feature is that you get query and response privacy. So if somebody asks a question in GNS, neither the zone public key nor the label become public knowledge. The servers answering those queries do not know what the question was, and they do not know what the answer was. So the record can remain a secret between the zone publisher and the person performing the name resolution. Of course, under the assumption that the zone or the label remains secret as well. Because of course, if you can ask the same question, you should get the same answer. We also have globally instant and reliable key revocation implemented in the system. And we can support DANE records. So basically, it can also serve as a PKI. Next. So current status, we have a draft, was on the independent stream editor track. We have passed there. We're now in the IESG conflict review for a while. In part because it was a difficult one, I hear, but in part also because we've been waiting for the .alt draft to progress. We have two different implementations in C and Go. We've done a usability study that basically shows the users wouldn't even know that they're using GNS over DNS. And we have a way to migrate DNS zones into GNS automatically. And we run this on large zones like .fr or .se that we have public access to. You can install the software and run it if you have an appropriate free software distribution. Next. Okay, so as we can resolve DNS names in GNS, there's of course this possibility of having a conflict. The .alt draft tries to address this challenge. It doesn't specify a registry for .alt, which I personally think is a mistake. The GNU Net project runs the Ghana registry, where we are putting in a registry for .alt. So you're welcome to come to us if you want to have your own protocol under .alt, and we will be happy to run such a registry. I think it would be good to put that into .alt draft, but okay. Now, of course, it's free software. Users don't have to stick to gns.alt. They could put any domain in there and resolve names in that domain over the GNU name system. And that's actually okay. For example, if you had somebody who was publishing .li or .nu under the GNU name system as an alternative way to access those zones, you might want to say, okay, I deliberately want to overwrite DNS here. For this zone, I do not want to use DNS. I want to use GNS. And that's okay. But in cases where you don't want a conflict, then .alt is useful for a user to use. And of course, then we recommend that. Next. Okay, so to conclude, GNU name system proposes a radical alternative for the obsolete DNS protocol. We have specifications and implementations and migration logic. The .alt draft will help address conflicts where they would be a problem for the users. And we have a draft for the DHT that's used below if you're interested in further developments on that specification. Thank you.
I do it formally after Benno. Yeah, I'll wait, and it's George.
You run the queue? I can run the queue. Warren, you're first. Please go ahead.
Hi. So two things. First off, I just realized that I still owe the GNS authors, or actually, I guess the ISE, a email reply. I just found a thread that had been lurking at me, so I will hope to reply in hopefully by the end of the day. And then also for the working group, as you all probably know, I got tasked with doing the conflict review thing. There's been a lot of discussion with the ISE, and I have most of the text written up. I can't remember if it's in the tool, but my position is going to be that this work is closely related to work done in the IETF, in the DNSOP working group, but that it doesn't prevent publication of the document. So, related, but the ISE can go ahead. I did want to remind people that there's a very limited number of conflict review positions that can be put in. They're largely, this isn't related to anything, whatever. This is conflicts directly with work in the IETF and should not be published. And those are sort of the main overview of the positions. There is some nuance. So just so everyone knows, my position is because, we've worked with the authors and the ISE to make it so that this won't conflict directly because of the suggestion to use alt. The position is going to be, related to work, does not prevent publication. Hopefully that was coherent. I will try to clarify if that wasn't.
Thanks, Warren. I think Wes is next, or George?
No, I'm late. I think Wes is next.
Okay.
Fair enough. Wes Herdeker, USC ISI. I'm on the IAB and also on the ICANN board. I have a couple of thank yous to start off with. First off, thank you for encouraging the use of .alt and actually doing that separation. The IAB, as you know, has a document that is quite old saying, a unified namespace is beneficial to end users because it gets confusing if it's not. So greatly appreciate you guys' willingness to adapt to that. Second, thank you for all the cool technology that is in, this. I've said this before, I've read the GNU DNS specification before, and there's a lot of cool math that, I think is pretty novel and, will help even if it's not used in the future, which I hope it is, but even if it's not, it will still drive new technology. And so thank you for that.
Yeah. We felt it had to be documented as an RFC.
Yeah. One final point, though, is that everybody's been concentrating on the naming conflicts at this point, especially with respect to TLDs and things like that. There's other conflicts in the document that I have a marked up written of the document that conflicts with the DNS protocol in other ways. For example, you're reusing RR types, but you have a larger field. So you've essentially co-opted the rest of the numeric values beyond the existing IETF specifications. So I'm not saying it's good or bad, right? But if the IETF was ever going to try and expand and then you were using those numeric fields beyond the IETF's current range, rather than sticking to the for your own use section, you're using a significant expanded set of fields. So that could be a conflict that people want to explore as well.
Yeah, I mean, we deliberately said, okay, the current DNS protocol only allows these 16 bits, and they seem to be enough for the foreseeable future. So we didn't see a reason why DNS would expand it. And so we used the 32-bit address space to avoid record type conflicts and said, the lower ones are the ones of DNS, and we're going to stick to that. And we're only going to use those above 2 to the 16 in the hope that this would not generate conflicts. Now we have the Ghana registry where our types will be registered. And of course, if the IETF in the future were to decide that they need for some, for me, incomprehensible reason, more than 2 to the 16 record types, we might just combine the two registries to avoid conflicts on that level as well, I think.
George Michelson, APNIC. So I think I probably have more philosophical observations than technical, and they may not be helpful. So perhaps this is pointless. Could you re-roll to slide 6, please? Back to.
No.
So you use this word on slide 6 about, by implication, the registry function, that you're going to implement the registry function to resolve differences between parties and to refine who has delegation under .alt. And I struggle a little with that concept set against the idea that .alt is effectively structure free. And I understand first occupant has some expectation of behavior, but this becomes a process question, which is not really a technical question, it's a process question. Who is adjudicating these delegation questions?
Well, I went to this working group about 10 years ago, and we said we have a bunch of special use top-level domains like .onion, which was effectively passed, .I2P, and so on, that were not. And the goal was to avoid conflicts with the DNS namespace, because as we just heard, a unified namespace is beneficial for users.
Highly beneficial, highly beneficial.
Probably beneficial.
Highly beneficial.
And if that is our goal, that we avoid these kinds of conflicts, right, then the best way of doing, this allocation is to basically say, okay, this is actually a real implementation effort, an actual protocol design that deserves to have a unique suffix, so to speak. And that's the only education we're going to do is, first come, first serve on somebody who implements a new name system. And I think that's, again, beneficial to users that want to have this conflict avoidance, which for me is the main motivation behind .alt.
Yeah.
And not this, we need something completely unstructured Wild West where users will not have this common expectation of names not having conflicts.
No, I think by motivation, you are in a very similar headspace to many people. The problem being that we have structural behaviors around the creation of these entities, and they come with legalisms and requirements for behavior that are not technical and outside scope of this room. But I was intrigued you put them on the slide. So the word reserves kind of took me there. The second part is the collision of protocol RR types. That is a registry function, right? So, I mean, if you front up and say, hey, we're starting to consume these, you shouldn't be spinning an alternate registry of use. You should be lodging them in the same registry.
We tried, and we were refused IANA access, so therefore we started our own.
Thanks, George. It sounds like there's a lot more to discuss here, and I hope you'll be available for folks who want to discuss further, but we do have to keep moving on our agenda here. Elliot is still in the queue. Elliot, you get a brief last word.
Good evening, good afternoon, good morning. And first of all, I just would like to add my thanks to the working group and the authors and the ADs. As the independent submissions editor, I wanted to make one clarification and one request. And by the way, it's a pleasure to see the authors in person or on video because we haven't actually met. The independent submissions editor has not yet made a publication decision. That happens pretty much at the end of the process. Furthermore, I'd like to just also invite people in the room, virtually speaking, if they have comments on the draft, of course, please send them to the independent submissions editor, and I would happily entertain those, and I'm sure the authors would benefit from those. So thank you very much, and have a great rest of your meeting.
Okay, thanks. And next up, oh, too many windows. Cyril on structured error data.
Hello, good morning, everyone. I'm Thiru. I'll be talking about the updates to the draft, mainly addressing the comments that we received during the working group adoption call. Next slide, please. I think so far we have addressed all the comments that we have received, and we have few discussion points. Next slide, please. Yeah, so I mean, as we all know, this draft defines the sub-error codes. What we did was added citations for each of the sub-error codes, so it makes quite easy for to have unambiguous definition of each of these error codes, and added a registry for future sub-error codes to be added as well. Next slide. Yeah, so what we have done is we have mapped these sub-error codes to the error codes that are already defined in RFC 8914. So basically all these error codes map back to either blocked, censored, or filtered. And we had a good discussion internally on why was there a need to use forged answer, and we thought it was not required. Next slide, please. That should give an explanation. So what we thought was the forged answer basically is forging the response, and the client is losing the DNS error response, which is blocked, censored, or filtered, which gives additional meaning to these sub-error codes. So in this specific case where it is EDE supporting client, which is using these extended error codes, we felt there was no need to use the forged answer for the clients which support EDE. Next slide. So we did a bunch of changes to address, to explain the changes, how it aligns with RFC 8914. And we also added information to say that the information in fields, especially the contact, justification for blocking or filtering a domain, and the organization fields will be only displayed if the resolver has sufficient reputation. To address the comment with regard to UTF-8, we extended it to allow UTF-8 as well. But we couldn't address the user preferred language. We have the same issue as RFC 8914, and the other challenge that we saw was if that negotiation were to happen, it would probably have an impact on the client privacy. So that was the only issue that we were not sure how to address with limitations that we saw. Next slide. Yeah, so since we have already defined several JSON attributes, we were thinking what is the best way for future specifications to add new attributes to this INR registry, whether we want to go with designated experts or a more restrictive policy by requiring IETF review. We would like to hear comments from the working group on that. Next slide. Yeah, the current version for the sub-error codes requires an expert review for registering new sub-errors. We can use the same policy for even the JSON attributes, and we would like to hear comments on any other additional items that we need to record in the guidelines for adding new sub-errors and JSON attributes. Next slide. I think that's about it, and we would welcome more review and discussion on this draft. Hey, Ben.
We can't hear you, Ben. There you go.
Ben, we can't hear you. Ben, we can't hear you. No.
Test.
Yes.
There you go.
Yes.
Thank you.
Sorry. I'd like to see these registries be pretty tightly controlled with IETF review.
Okay.
I think there are a lot of places in the world where a return type code to indicate why something is blocked, where the legal system would love to have a return type code of blasphemy to explain why something is blocked. I think that there's high level of policy sensitivity here, and I would not want to put that on a designated expert. I think that ultimately the IETF needs to have the change control there.
Sure, that makes sense to me. I mean, we can add IETF review with specification required. Yeah, that shouldn't be an issue at all.
Go ahead, Tommy.
Hello, Tommy Polly, Apple. Yeah, I think for the review, I agree with Ben. I don't have a particularly strong opinion there. I think either works. The two things I wanted to say, one, I just filed the issue as I was reading this. I noticed that the document cites some like specific browser strings about what happens if you see cert errors. I'd love to see that be a bit more generalized, because that's one snapshot and also like assumes that browsers aren't looking at extended DNS errors at all. So I think, something that we probably don't want in the RFC, because it's going to get out of date soon.
Yeah, that was added to in the initial stages to get it going. But yeah, I totally agree.
Right, we've accomplished that goal.
Yes, yes.
Then the other question I had, and I can file an issue, but I just wanted to hear the author's opinion. There are certain fields like the contact info that are marked as mandatory.
Yes.
So I think I understand the rationale for that of, don't block it and give a reason and not tell me how to follow up. But in that case, this field is kind of expecting it to be some specific contact URI types. I think there are cases where there may be other context, or but let's say we add more fields here that potentially could supersede needing contact in that format. And so I'm just a little bit concerned about being mandatory, that you have to come up with some telephone number or email address. For example, there are cases today where we allow a DNS configuration to be installed by an application that can say, I want to configure this encrypted DNS service for my whole device that does this filtering. In that case, there may be, we may know better remediation or contact info of switch to the app on your phone that provided this, and that's where you do it, and we don't necessarily need a telephone number or an email address there. So I just want to make sure that we don't paint ourselves into a corner with making certain things mandatory that may not be relevant in all scenarios, or may get superseded by future entries in our registries.
Right.
No, I meant we don't paint ourselves into a corner as this group. Oh, sorry, yeah. Some client operating system or browser or application, whoever is processing the error, if it is just getting the error from a DNS server that comes from DHCP on your local network, absolutely it's going to be useful to get contact info. But there may already be other context in how that DNS resolver was provisioned.
Sure.
That will not be necessary to include here as a telephone or email address.
Yeah, that makes sense to me. In fact, if you see that field that we have defined, we don't in fact define what should be there in that, but we give suggestions like it could be SIPS URI or a telephone format or something else, because we were not sure what are all the contact mechanisms that could be there. So we just give examples on how it would look like. So we are not mandating on whether it should be just a telephone number or a SIPS URI. So they're just examples that were quoted there, if my memory serves right.
My impression is that you do need to include some value for this C contact entry, and it does need to be a list of URIs.
Okay.
So I'm just worried that may be a little bit too narrow. If we may have people end up putting just placeholder URIs in there because it's the thing that they want actually isn't a URI, it's some other context they have.
Sure.
Thank you very much.
Everyone.
Thank you for the feedback. Up next, there will be a remote presentation. Yeah, I will hand over the.
I'm standing so that he can throw tomatoes at me.
Hi, good morning.
I will.
Can you hear me?
I do hear you. That's interesting. It's still showing my slides. One moment. Let me should stop sharing. Yeah, that's better. That's better.
Hi.
There you go. Yeah, you're in control. So I think you can run the show now.
Can I show the slides?
I grant a screen.
Okay.
So you can share your screen now.
Okay, thank you. Thank you. Can you see the slides?
Yeah, excellent. Thanks.
Okay, perfect. Good morning, Gianpaolo Scone from Vodafone. I'm presenting an implementation of extended DNS errors to improve the browser user experience with network-based malware protection. So this is for customers that are subscribing network-based security products, for example, Vodafone SecureNet. The traffic flow in this case is in case of a clean request, the operator DNS responds with the proper IP address. In case of a malicious content, the operator DNS responds with a blocking page. It was all fine before the encryption era, so in case of HTTP request, it was possible for the customer to see a blocking page, so good user experience, but high risks of man-in-the-middle attacks. The customer understood the reason of blocking and was aware of the protection. After the rise of encryption, there are much lower risk of man-in-the-middle, but the user experience is bad. So we are still able to protect customers, but we are not able to show the reason of blocking. Customer is angry. He doesn't know if it is a network error, an error of the application, and so he doesn't know why he cannot reach the destination. But with DOH and the DNS extended errors, there are the basis to implement a better user experience. Now we are able to block and enrich the DNS response with the extended DNS error code. In this case, 17 blocked and with the reason and the provider. This is how it looks under the cover. So I dig, we see that we have the 17 filtered, the URI of the blocking page, reason malware, and the provider of the blocking. In this case, thanks to this RFC and the structured error data for filtered DNS, it's possible to enrich DNS errors with the reason of blocking. We have designed a plugin for Chrome to show the benefit from the user experience perspective. And this plugin can intercept the DNS request and in case of blocking, read the extended DNS error and show the proper blocking page. I can go to a demo. Just a second, if I can change. So please, if
You might need to allow it again.
Yes.
Thank you. So in this case, I enable the extension. This is a fake malware page. And in case the plugin enabled, I see the blocking page with the logo of the security product and the reason. There is an explanation so that the customer can be aware. We can have several levels of blocking. In this case, I block also for parental control reasons. So this is a fake adult site. And while it is blocked, I can see it blocked for parental controls reasons. So going back to the slides.
You have to request access.
Yes, sorry. Yes.
Yeah. Okay, there you go.
Okay, thanks. So we see that instead of seeing a page without meaning, so that the customer is not aware of the reason of blocking, we can see a proper blocking page. This is just a plugin, so this is used as an example, but better approach will be the integration in browsers to improve the user experience from the perspective of the customer, so that the customer is aware of the reason of blocking. Thank you.
Okay. Thank you. Wes, you are in the queue.
Thank you, Wes Hardiker, ISI, and one of the authors of the EDE RFC. So this makes me super happy to actually see this type of deployment. A couple of questions. One, I think the obvious one is the web is not the only environment. So you're not combining this with like address redirection or things like that, where you're spoofing responses that don't exist. You're only returning EDE codes for real data that would exist.
So the actual return code is, as you saw, an X domain. So when we want to block stuff, we don't want people to go there. So in the old days, as Jan Kapal said, we would have returned an IP address of a web server. These days, we only do an X domain, and then the actual web page that presents the block page is in the EDE error.
Okay. And what happens with supplemental content like images or JavaScript or CSS?
Well, these are all kind of different DNS requests, right? It depends on the list that you have that for blocking.
But you could have a main page that's okay with content from another name that you are blocking. And so what does the UI do in that case? Where the main page, domain is fine, and you're requesting CSS from malicious.com that then you can no longer use because it's being blocked. You can't show the error code as well, right?
You probably you have to show it in the small window that you get for that. Yeah, I guess.
Yeah, when we were discussing the draft, one of the major comments was not to display any new pages, right, beyond the error codes, so that the browser would render them or an app would render them. So the idea was you don't want the end user to go to some other page, which would probably mislead the user into something else. So that's the reason, if you see, most of the error codes are pretty much standard ones, so that the application itself would display the appropriate message back to the user without any images or any JavaScripting or anything like that. It's plain old simple messaging to know why it got blocked, to avoid any misuse by any of the DNS resolvers to point the user back to some other web page advertising something or asking the user to do something else.
I think it's a good approach, yes, also to have only the text that explain the reason.
Okay, thank you very much. So, question to the author, to you. So, what do you think the status of the document is? We have you have comments from Paulie, the presentation here.
Yeah, I think we should be able to address both the comments from Ben and Paul, and
yeah,
we will publish it in a couple of weeks.
Okay, excellent. Thank you. Then, thank you, Joe Paulo, for your presentation.
Thank you.
Okay. Next up is Shivan, the presentation. Sorry, you want? Yeah, I can pass access. Yeah. Right, there we go. Okay, 1 moment.
Cool. There's so many presentations.
Slide control.
Yep.
Yeah.
Isn't that sure?
Okay.
Okay, cool.
There you go.
Thanks, Ben. Hey, all. Shubhan, Paul, and I have been working on domain verification techniques. Sure. Is this better? Oh, perfect. Cool. Yeah, so we've been working on a draft for a while. It was an informational draft, but then folks said that it just makes sense to make it a BCP. So we've been kind of plugging away at it for a while. And yeah, as was mentioned, we did a last call recently, and we had some comments. So I'll go through some of the changes we're planning to do, and folks can opine about what they think about that. But just as a refresher, what is domain verification? The idea is that many providers on the internet need people to prove that they control a particular domain before granting them some kind of privilege. So, for example, a great example is Acme, which has a DNS-based challenge for a user to prove that they control a particular domain, and hence they should be issued a certificate for it. So, and yeah, and previously we had just a survey where we talked about text and CNAME. And then with the BCP, we said, okay, so it seemed like text was just the right way to do it, and CNAME might lead to issues. But then we did get some feedback that maybe we should still keep CNAME, but not recommend it, and just say that this is an option that folks can do, but we still recommend using text. And not be too prescriptive about the fact that people cannot use CNAME, because it's definitely a thing that people do right now, and is fine. Yeah, so this is kind of like what a domain verifying record looks like, and we're saying that well, one of the things that the BCP talks about, or draft talks about, is that you should have this underscore foo to the left of the name, so that you can identify what you're trying to verify. And then Paul said, like, there's a use case for having the expiry built into the record, so that just looking at the record, you can see that, okay, this is a record that I'm no longer using, and I should get rid of it. And just to, I guess, remind folks, the idea behind this draft is that in practical deployments right now, it's often like there's often tons and tons of records that really bloats up the DNS response, and then you kind of have to fall back to TCP, and that leads to issues. So that's the suggestion was to make it very clear in the record itself when the record can be removed. So this makes sense, even though this is not something that, for example, Acme does right now, but we offer this as an option that if you really care about just putting everything and being extremely clear, then you should do this. Or you could also say that it should never expire, but if you're doing that, then you should just say that and not just kind of hope that no one's going to remove the record and then stuff breaks. And then you can also have, if you have multiple features that you're trying to do, then you can just kind of keep prepending to the left. So you have like underscore feature one as an example. And we're also saying that you must provide clear instructions on when the record can be removed, either through putting that in the record or through like some help text. And then we also say that you should have detailed help pages. There was one question about DNSSEC, and we currently in the draft we say that clients should have DNSSEC signing, and service providers must use it if clients have it. But perhaps this should be less strong and just be a recommend. Happy to hear what folks think. And that's about it. I think everything else was just clarifying text stuff. So yeah, so I guess happy to hear about what folks think about those things, and yeah, if generally like what people think about publication. Thanks.
Thank you, Sivan. Any questions? John at first. Oh, sorry. Sorry.
Hello.
Oh.
Okay.
Well, please go ahead. Yeah, sorry.
Yeah. So my name is Yasuhiro Orange Morishita at JPRS, and we demonstrate. So we deliver the technical information is our first day host equipment demos in using your draft. I want to discuss this draft as after DNSOP sessions, so I want to add recommendation for external DNS service providers, and ensure that underscored subzones of existing zones cannot be configured by other customers on the same authoritative DNS servers. So the underscore name, underscore level, so at leaf is must be the same owner.
Just be the what, sorry?
So underscore at the leaf underscore level is the same owners of the apparent zone, apparent domain.
Mm-hmm. Okay. Maybe we should like talk offline because I'm not sure I understood like exactly how this would work. But maybe we should talk offline about this because I'm not sure I understood exactly the whole thing you said in the beginning. So yeah. So.
Okay, hold on. Before we go on to the next speaker, 2 reminders. We are being asked to wear masks in this room. And also, please get in the queue from the app so that we can manage the virtual queue along with the physical queue. Thanks. Go ahead, John.
Yeah, I'll find you afterwards and we can talk.
Yeah, John Levine. You probably noticed I had some fairly testy exchanges with Paul about this draft. Yeah. I think it's actually considerably improved. And I have sort of one and a half suggestions. One is, I think you could make it clearer what parts are intended to be mechanically interpreted and what by humans, but particularly the thing like the expiration date. It's like,
right?
Yeah, like it would be if you could recommend, put the expiration date in this format so you can have something that scans your zone file and takes out the junk. That would be that would be nice.
Okay.
And I think you could also make it clearer why, even though everybody uses, the reality is CNAMEs are very popular.
Right.
And in the discussion, there were some things about like why some of the naming issue, beyond what you say with the CNAMEs colliding with other stuff, like putting long complicated names is harder than putting long complicated contents, which I'm not sure I believe, but at least it's a plausible argument. So I think you're pretty close. It's just like, so given that people have been doing it ways you do not recommend for a long time, it would be nice to make it clearer why you're recommending doing it this way rather than that way.
Yeah, I think especially for the CNAME part, yeah, I think you're right. I think we should just give more clarification around like why we're suggesting that. Yeah.
Wes Whitaker, ISI. To answer one of your questions about, should DNSSEC be, mandatory for verifiers, for service providers, excuse me. The DNSSEC proponent in me says it should be a must, but I recognize that that's not likely the right solution. So recommend seems good. What I would encourage you to do is put in additional text, however, that says you must use some mechanism to reduce the chances of a client spoofing or cache poisoning or something like that, which may be something like what Acme does is, query from or Let's Encrypt does, querying from all over the world trying to prevent that. But make them do something, but DNSSEC being a.
So yeah, I should have mentioned that we actually do say that right now, but it's okay. That's perfect. That's exactly the feedback we wanted. Thanks, Wes.
Thank you. Okay. Thank you very much, Sivan. Yeah, good discussion and can make good progress with the draft. Yeah. Thanks. Cool. Thanks a lot. Next up, Schumann. Yeah. You want to run the slides? I will run the slides.
Would you mind advancing them? Or?
Yeah, no problem.
Thanks. Can everyone hear me okay?
Yeah. Yep. Sure.
All right, great. So I'm Schumann. My collaborator on this draft is Christian Elmerod. And he's not here in person, but I believe he's online. So I'm hoping he'll chime in with comments as necessary. Next slide, please. So today I'm talking about a new draft, but which describes a method to do authenticated denial in DNSSEC, which has been around for a while. It was originally devised by Cloudflare and described in a now expired internet draft from 2016. At that time, it was called Black Lies. So we've since renamed it to just compact denial of existence, or compact answers if you prefer something more pithy. It is widely deployed amongst a set of commercial online signers today in the industry, notably Cloudflare NS1 and Amazon Route 53. And one of its distinguishing and controversial features is that it eliminates NX domain responses completely. So, or at least the traditional conception of NX domain. And that, as you might expect, has some operational implications. Next slide, please. All right, so what this does is for names that don't exist, these implementations pretend that it does exist. It just doesn't have any resource records for the type you queried for. So in other words, it returns rather than an NX domain response, a no data answer. And crucially, in that answer is a dynamically generated and signed NSEC record with proof of the no data. And the stated rationale, stated benefit for this scheme is that we get more compact answers. So a signed no data response requires just one NSEC record and its corresponding RRSIG. You get higher performance because since there's only one, you only have to do one online cryptographic operation to generate the signature. By contrast, an actual NX domain responses requires 2 NSEC records, or if you're using NSEC 3, up to 3 NSEC records to prove not only one, that the name didn't explicitly exist in the zone, but also that it could not have been synthesized by a wildcard. So there's more computation and increase in the size of the response. So there's another reason which I sometimes forget, but Christian reminded me of recently, that a lot of these implementations, for whatever reason, and you can debate whether this is a good idea or not, but they have challenges understanding the tree structure of the DNS zone. So for an NX domain response, what you need to do is you need to find the ancestor of the name that didn't exist, compute the closest closer so that you can generate the proof that a wildcard couldn't have generated the answer, right? So that's a concern. We can have a debate about whether that's the correct way to implement a DNS zone, but I don't think this is the right way to do it, the right place to do that. There are lots of these implementations out there in the industry by many companies. So next slide, please. All right, so what are the operational implications of this scheme? For typical end user applications, probably nothing. In most cases, a no data response is treated almost identically to an NX domain. There are, however, a no data result can result in additional follow-on queries for additional types of the same name. And this actually has been observed, and it does happen because if you think of the very common case of a dual stack host, a common DNS query pattern is a quad A followed by an A. So if the quad A didn't exist, an NX domain would have immediately suppressed the follow-on query, whereas in this case, it will generate those additional queries. But apart from that, there are a variety of diagnostic troubleshooting and traffic characterization tools that may be impacted and have to deal with this new protocol, especially tools that commonly rely on the correctness of the DNS response code. Now, arguably, we could say that in the age of DNSSEC, you can't trust the response code because it is unauthenticated and can be spoofed, right? But if that's the case, then what we have to do is infer the non-existence of a name by looking deeper into the packet and signed data records, specifically the NSEC records. And the question is, can we reliably infer the non-existence of a name from that? So next slide, please. And the quick answer is there's a problem because It turns out, as the spec is currently written, there is no way to distinguish NX domain from empty non-terminal names because they share the exact same type bitmap. There are some implementations out there that kind of hack around this with a workaround for empty non-terminal responses. They basically display a wide type bitmap, which is composed of every record that they support except the name that you queried for. But this has other implications because then you've lost distinguishability of empty non-terminals, you've potentially bloated the size of the type bitmap, and you could potentially confuse tools that do type inference from the type bitmap. So this is essentially a hack, and we want a cleaner solution, not a hack. So next slide, please. All right, so what can we do to fix the situation? So essentially what we need to do is we need to introduce a distinguisher protocol element in the response, either for NX domain or for empty non-terminals. I suppose you could do it for both of them, and I think somebody suggested that on the mailing list, but really you only have to do it for one of them. In another expired draft, I previously have proposed an empty non-terminal distinguisher, and that has actually been implemented and deployed in the field by NS1 and is successfully used by us. And there were some specific technical reasons I chose the ENT distinguisher, and you can read about those reasons here, but let's just skip on to the next slide. So here's an example of that in the field. I think this is a real example. You'll see this is a query for an empty non-terminal ENT1 dot blah, blah, blah. And you'll see there's a synthetic type stuffed into the NSEC type bitmaps at the bottom right of the screen right now using a private type code. Next slide, please. And now we'll move on to the new proposal in the current draft is that we are instead proposing to do the pseudo-type distinguisher for NX domain instead. The mnemonic we're proposing for this is NX name, which stands for non-existent name. And we deliberately chose not to use NX domain just to avoid any confusion with the response code mnemonic of the same name. Our plan is to use the lowest available RR type in the meta type range. And last I checked, 128 is still available. And very recently, Cloudflare, I think maybe a week or 2 weeks ago, but Christian can probably tell you exactly, but Cloudflare has recently done a preliminary implementation of the scheme for now using a private RR type code. Although I should say that our plan is to ask for IANA for an early allocation of the real type so that we can get this stuff deployed in the field as soon as possible. Next slide, please. And here's an example of the final form of what an NX domain response would look like after this. So the response code is still no error. However, the NSEC type bitmap has this special synthetic RR type NX name stuffed into it. Next slide. Yeah. All right, so what about the question of restoring NX domain in the R code field itself, which a lot of people really want to happen? And that's a little bit more challenging for various reasons. But it turns out we may have to try to do this, or at least make our best effort, because as I mentioned previously, there are tons of tools that only know how to examine the R code, and they are currently broken in the face of these mechanisms. In theory, you could work with the developers of those tools to enhance them, to instead of looking at the R code to recognize the NX name signal in the response. But the question is, will that ever happen? How much work is involved in doing that? On the resolver side, we could, for non-validating queryers at least, a resolver that recognizes NX domain could substitute the NX domain back into the R code in responses that it relays back to those queryers. But I think we really need to have a solution for validating queryers as well, things that send do equals 1. And the related question is there a way to put the NX domain R code back into the response that is generated from the authoritative server itself? That's more challenging. And I think the only way I know, at least to do that, is by implementing new eDNS signaling with its complexity costs. I think I've received some pushback about it, but at least we should think through that option. Next slide, please. All right, so here's a link to the latest draft. It tries to describe completely the current compact answer scheme. It also describes the new NX name distinguisher RR type, and there is at least some preliminary discussion about R code substitution schemes. Next slide. And finally, my question to the working group and to the chairs is, are we ready to adopt this draft? To reiterate, compact answers is widely deployed in the industry today, and yet it has no formal published specification, and I do not think that is a good state of affairs, and we should do something to fix that. And also to make it work better by precisely specifying an NX domain signal, which is what we're trying to do. My assessment is there seems to be a lot of interest in the draft already. There's been a lot of email on the list. I pointed to some threads here. And finally, I will mention that additionally, I have also spoken to NS1 and Amazon Route 53, and those discussions have been positive. They're both amenable to adjusting their implementations to incorporate the new NX domain signal. And with that, I will stop for discussion and advice from the chairs about next steps.
Yeah. Thank you very much, Liman. Sorry. Sorry. Thank you very much, Schumann. Liman, please go ahead.
Hi, Lars Lehmann from NetNode. Just a very quick question. Does your draft recommend to handle this situation differently depending on whether the DO bit is set or not?
Oh, yeah, that's a good question. So I think that suggestion has been made on the list. Currently, it does not, but I think we will mention something. So if for do equals 0 queryers, we don't have to deal with the DNSSEC proof, so we can just return a traditional NX domain response. This is what Cloudflare in fact does today, but some of the other providers don't, so we can recommend that. So the question I have though is, you could ask, is it worth doing it if most resolvers today by default send do equals 1 query, regardless of what the downstream querier does, right? So that's an open question I have, but I'm, at least in principle, open to documenting that, if it helps.
Thank you. Yes, please do. And a small comment that it may actually have an impact on the resolver, because the resolver may say DO1 and do the validation, arrive at something, and maybe it's actually better to substitute and send the NX domain going down to the end client.
Yeah.
So that's something that I would like to have at least described, that process described in the document.
Sure. Okay. Yeah. All right. Yeah, I get it. So there's some nuances in that discussion, and then yeah, I'll make a point to discuss it in the draft.
Thank you.
Yep.
Okay. Victor, please go ahead.
Okay, my mic is on now, I hope. I was also going to mention DO equals 1 versus DO equals 0 as an issue at the resolver response, not the authoritative server response. So that's important to consider and specify. And that's where much of the complexity arises, the cost of supporting this is having the resolver, transform the response depending on how the client asked. Gets complicated. The other thing that should be specified clearly is the behavior of actual queries, made, to probe misbehavior perhaps, but somebody might deliberately send queries for an NX name to, give the resolvers a hard time of the world, and perhaps authoritative servers. How should either of those respond? Needs some consideration. Do you actually then pretend that there's data at the NX name and mollify the existing unaware validating resolvers that will happily see some sort of empty-ish but record for NX name, or what do we do? So those, I think, are the key things to flesh it out fully. And there was, I guess, on the list, or DNS operations perhaps, a point that it may take a while for the current implementation to go away. And in the meanwhile, we have confusion, and that's why there was a demand for making both and NX domain be sentinels. I don't know if that's a compelling argument or not.
Yeah, thanks, Victor. So on your, I'll work backwards. So on your third suggestion, yeah, I mean, in principle, I'm okay with that, especially if it takes a long time for implementations to change to adopt the current recommendation in the draft. I'm a little bit more optimistic. I've spoken to all these vendors, and I think my impression is they can quickly change their implementations. I could be wrong. But if they can quickly do it, it's probably simpler to just have one distinguisher. But I think it's not the end of the world if there are distinguishers for both NX domain and empty non-terminals. On your middle point, I'm trying to remember what that was. Oh, right. Yeah. Okay. Yeah. I agree that, yes, the draft should mention what should happen if a resolver deliberately sends a query for the NX name pseudotype, even though we don't expect normal software to do that. So I was thinking about that, and I think the default behavior might be okay. It might just work. If you send a NX name query for a name that doesn't exist, you'll probably just get a no data answer back, right? But we could specify that. And for something that doesn't exist, then yeah.
Right. Can't send no data. The bitmap disproves it.
Correct. The bitmap disproves it. Yeah. And the non-existent name thing is a little bit more complicated. It depends on whether the authority understands the scheme, is using the scheme or not, right? But either way, I think we can write up a succinct description of what we expect to happen if we accidentally get these queries from whoever or attackers, etc. And on your first point, yeah, I think I agree. We'll describe the do equals one behavior on both sides, at the authoritative server and the resolver. Thank you. Thanks.
Guess I'm next, Jim Reed.
Yep.
Shimon, thanks very much for a very clear presentation. I've got a much more skeptical view of all this stuff. This seems to me to be rather ugly from a protocol point of view, and I don't think that's the way to solve the problem we're talking about here. And I also think this is a hell of a lot of work just to shave a couple of bits or a couple of bytes off a response. I'm not sure if that's the right cost-benefit calculation has been done here. It seems to be a hell of a lot of protocol work or a hack on the protocol just to save a little bit of data. And also we've got the problem here now with the servers generating signed data on the fly. The servers might not have access to the keys to be able to do that.
Mm-hmm.
So I don't think this is really a good idea. I'm skeptical about it. If it does go forward, I would think it would need to be an informational, not a proposed standard RFC.
Okay, so Jim, let me ask a clarifying question. It sounded to me like from your description, you're skeptical of the compact answer scheme in general, not the additional tweaks we're putting in to recover the NX domain signature.
Correct. I don't think it's worth the hassle for the saving.
Yeah, I agree. I mean, when I first encountered this scheme, that was my same thought, and I think a lot of other people in the community share that opinion. But the truth is, these implementations are already out there, and they're being used at a fairly large scale, and I don't see it likely that the situation is going to change. So what we can do is try to improve these protocols.
Well, yeah, I could accept to have a document that says this is a spec for this stuff without just so we've got the degree of interoperability between these implementations. But I don't think this is something we should be trying to encourage generally, because it's an ugly hack in the protocol, and that starts us on a very slippery slope if we keep tweaking things in this way and adding unnecessary complexity, in my view.
Yeah, fair enough. So let me, I don't know if Christian is on the line from Cloudflare, and if he wants to
he's in the queue.
Make a response. Okay, yeah, great.
Okay. I'll let Christian go first and he wants to respond to.
Yeah, okay, Christian, you're on, I think.
Hey, so rightly from a complexity question, I would actually say that this simplifies things quite a bit. But more importantly, we are already using this in production, and so are other implementers as well. So, and the issue is that these current implementations are not they're not the same. As already mentioned, NS1 uses the Sentinel, and we have just recently, last week, started to implement the NX name signal. So the idea here is that we can get together on and implement a standard for all of us, which then can be interpreted in the very same way by resolvers and clients.
Yeah, okay, thanks, Christian. We kind of agree and disagree. I still don't think this idea is as simple as you're claiming it is. We're going to have to add more code to name server implementations. So in my view, that's adding complexity. You're going to have to write code to cope with this stuff. So that adds complexity, in my opinion. As far as documenting something so there's an interoperable way of doing this thing, even though I think it's a bad idea, I'm quite happy with that.
So there is no, let me just respond to that. You already have to deal with this today. And if you don't add any code to deal with this today, you don't have to add any code to deal with this tomorrow, to be honest. If you want to upgrade these answers to sort of actually see that this is NX domain just responded in a different way, then of course you will need to add code. But you don't have to do that. But then again, you don't get the benefits of this. And
fair enough.
This isn't something new situation. We have always had this. Anytime you add something, either you implement it or you don't.
Okay, I just said I wouldn't like to see this in a reference implementation of the DNS, that's all. Okay.
Okay, thank you. So, yeah, we're a little bit short of time. So if you can ask the question, of course, but keep the time a little bit.
Yeah, it's actually a very short remark. So thanks a lot for doing this. I think that we need to document this, but in my opinion, we should make the impact to other players in the DNS ecosystem as kind of minimal as possible. So not have resolvers do anything special when returning an NX domain or something, but just really document it, have the NX name, and the rest of the ecosystem kind of deal with it.
Yeah, fair enough. That's a reasonable position. I think some other folks may disagree, and they would want our code substitution and things that make it easier for other tools. But yeah, I mean,
well,
thanks.
Yeah, there's plenty of room for additional discussion. What we are hearing is we need to take a formal call for adoption to the list and further discussion there. So thanks, everybody. Thanks,
Okay,
Shuma.
great. Thank you.
So next presenter will be Peter Thomason, remote.
Yes, hi. Hope you can hear me well. Can you?
I can hear you, but not very loud.
Well, let me just try to ramp up my mic 1 second. Okay.
Okay.
Better now?
Yeah, the slides are up, or you want to
Okay.
run themselves? Yep.
You can do it. It's just a few, so it's not worth changing.
Yep.
Okay. So I'm Peter Thomas. I've written this draft on consistency requirements for CDS, CDNSP, and CSync processing. I think I've talked about it the last 2 IETF meetings as well, and there has been some feedback. So I'll talk about updates and also about a new motivation that appeared. Next slide. Yeah, so very quick intro. When you do CDS or CDNS key scanning, the spec actually doesn't say anything about how the parent should poll. So the most likely thing for parents to do is to use standard DNS resolution, which ends up querying one name server. And the CDS stuff is used for automatic DS management, for key rollovers, DNSic bootstrapping, stuff like that. And if things go wrong, it has a potential security impact. So we should think about whether that standard resolution is the correct way. Then the csync specification is a little bit different. It actually advocates limiting queries to just one authoritative server. So it does say that explicitly under the CDS spec. But there's also a suggestion in the spec for csync that says that you can ask all of the name servers if you want, and then do some serial comparisons, not because of consistency, but because of recency. And so similar thoughts apply, right? It's used for delegation updates, name server and glue updates, and it might have potential security impacts. And then especially if you consider situations where serial is computed by, I don't know, one of several providers, like each does their own, then the freshness thing even doesn't make much sense, and you may end up with incorrect result. So if you ask a single name server only, then obviously you don't ensure consistency across authoritative name servers. And apart from the back and forth flapping you can get when there is two different record sets at two auths and the parent scans one and then next day the other, for example, there are quite serious failure modes in multi-homing scenarios with multi-signer stuff and provider change stuff. I've talked about this last time, so I moved to the backup if you want to take a look at that. But the main takeaway was that each nameserver operator is a single point of failure and can break delegations accidentally or maliciously, and that is not what registrants probably would expect. Next slide. There's also a new failure mode. I mean, it's not new, but it occurred to me. So there's a paper by Casey Claffey that is about an EPP quirk that sometimes prevents the removal of expired name server names. And then you can hijack at least part of the name of the DNS traffic if you manage to register that expired name and traffic, the query traffic, and you can send whatever responses you like. And you would think, okay, cool, DNSSEC does offer integrity protection against that. So that rogue name server wouldn't have any say. But as you know, about 90% of domain names don't actually use DNSSEC. And as long as that isn't deployed more, let's see what could be an attack vector here. So assume you have a domain with an expired name server, and then there are some other legitimate name servers still in operation. And now the hijacker launches stage one, so to speak, and they publish their own keys via CDS or CDNS key records. And if the parent happens to process that, then the attacker's keys will end up in the DS record set and will prevent the legitimate responses of the remaining authoritative name servers to be accepted by validating resolvers, and they will become bogus. So this breaks the availability of the legitimate name servers, even though they're still in the delegation. And then even worse, once you have that, the hijacker can publish an updated NS record set on their server, which is the only one whose answers will be validatable, and also publish csync. And then that way throw out from the delegation name server record set the legitimate remaining authoritative name servers, which finally breaks integrity of the whole thing. And that is exactly the opposite of what you would want, because the legitimate name servers have no presence anymore at all. And the attacker is in a position where they seem to be the only legitimate party providing service for that domain. So you could say that's kind of a constructed problem, but it is a way that could be followed. And in the 10 years where the study was done, or sorry, for the big data sample period, in that paper where it was investigated how frequent that kind of risk is, it turned out that a few 100,000 domains were exposed to the risk and about 1/3 were taken over, which doesn't mean that each of them was targeted. Maybe it was just a few name servers and they were hosting many domains, but it's not negligible, I would think. And yeah, so the draft essentially proposes all of that couldn't happen if you would check that the CDS records are consistent across name servers when you do the processing as a parent. And the only thing it requires is that you just ask each of them individually. Next slide. So this is actually the last slide. So the updates since the last IETF meeting are very minor. The basics essentially are the same when you process record types that start with a C as a parent. then you must ensure that they are consistent across authoritative name servers. And if one doesn't respond, that's fine. And you just skip over it, but it can't be that you get responses whose contents are inconsistent. I think Victor proposed to add an optional retry mechanism with exponential backoff for resolving inconsistencies. So I added that. And there's also minor editorial changes, plus the added motivation that I just talked about with the lame delegation hijacking. Now, one thing that occurred to me is that the CDS specification says that when you process that stuff, you must ensure that the new DS record set would not break validation. Now, that could also happen if you process a csync record set and, for example, replace the name servers in the delegation. Then it could be that, for example, they don't have the proper DNS keys in their zone or whatever, like the wrong RSIG algorithms. And there's currently no provision that you have to ensure that csync updates don't break validation, although csync does require DNSSIG. Yeah, it just occurred to me that that could be a thing that perhaps can be added to that consistency requirements document if the working group feels that makes sense. And that actually is the next question: what would be reasonable next steps? I think some people provided feedback already, and last year, sometime at fall, there was some discussion on the list about it. So there seems to be some interest. I haven't heard much negative feedback so far, in fact, not in public at all. And I just wondered if the working group thinks that should be something that should be generally recommended, and in other words, perhaps adopted and then published at some point. That's all I got.
Thank you, Peter. Are there any comments from the room? Someone cute? Yeah, okay. I see Victor is cute. Please go ahead, Victor.
I wanted to mention a corner case for csync. If somebody's willingly giving up a domain, transferring it to another party, and the other party doesn't want to do DNSSEC, the target name servers will be, will have an unsigned zone. And so validating the validity of the zone at the target won't be possible, right? A transfer from assigned to unsigned via csync can't work. No, we don't necessarily need to make that possible, but it's one corner case to at least consider whether it's in scope or not.
Yeah. I think one way to address this is that when processing CDS, we could consider ignoring, so your opinion would be interesting actually, we could consider ignoring any insecure responses we get and treat them like an unresponsive name server. And that would allow, even when for some reason the new provider that doesn't have DNSSEC is in the name server record set already, it would allow the old one to publish a null CDS record to turn off DNSSEC. So that could be done. But I don't know if that's the best way.
Johan?
Yes, this is Johan Stenstam. So I have two objections. Objection number one is that we've spent perhaps 15 years explaining to the world that if you have something that is signed by DNSSEC and it validates, then it's good. And this sort of breaks that logic by saying, except when it's really important. If it's really important, suddenly we have to talk to all the authoritative name servers just to verify whether they are actually agreeing or not. And I think that could have bad implications over time, saying, if it's really important, don't trust the DNSSEC signature, talk to all the authoritative servers, because someone else will come up at some point in the future saying, well, my stuff is really, really important. I'd better check all the authoritative name servers. And I don't think we want to go there. The other reason why I don't like this is because the authoritative servers are really proxies for the zone owner. They are proxies for the registrant. They are assumed to publish information that the registrant wants published. If they don't, as if they disagree or if it's out of sync or whatever. This is more of a reflection on a potential business issue, a potential choice of a bad provider, a potential disagreement between multiple providers or whatever. All of these are non-DNS protocol issues. They are business issues. And I don't think we should add complexity to DNS to deal with what is essentially not protocol issues, but rather business issues.
Thank you. I'm going directly to Wes. So we can take these points also to the mailing list for further discussion. Thanks.
Wes Herdeker, ISIN, author of the CSync document. It was 10 years ago, and I think I originally wanted to query all the name servers, not because of getting different answers, but rather to make sure that we always had the most recent version of something from an SOA perspective. But I lost that battle, I think, at the time, and I don't remember why. But the important thing is that the decisions that were made were about the robustness of keeping the DNS up and running, right? So if DNSSEC was required to do validation of CSync and all of the records that CSync was going to be updating, then you have to assume that the cryptographic validation with the key chain of trust is valid. There's no other, as Johan just put it, sort of a business relationship beyond that. The CSync and CDS documents can't fix that fundamental misconception of the upward hierarchy, not dealing with things appropriately. I look forward to the discussion about this in the future, though. I'm not sure where we should take it.
Thank you, Wes.
Peter,
before closing, you have, you can conclude your presentation.
Okay. So in principle, I fully agree that it's a goal of DNSSEC that you only have to ask one and verify one chain of trust. But I think precisely to guarantee that that property is a DNSSEC property, you have to make sure that the chain of trust doesn't break for accidental reasons, like one provider messing up a provider change. And I do recommend to look at the 2 backup slides when you have time and see how things can go wrong really easily in a way that exactly goes the opposite direction that I think people should expect to happen. And then very quickly, the second thing, there's already precedence for that, not specifically for what I'm proposing, but for cases where you don't just ask one question validated. As I said before, the CSync RFC says you may ask all of them. So that is already something that hasn't sent a very bad signal, as Johan is afraid of, that people will be doing it all the time. And second, the CDS spec, for example, says you have to sign and check that the CDS record is signed with a KSK and not with a ZSK, for example. So that's also a deviation from treating everything the same, and also hasn't caused any side issues of people wanting more KSK signing. So I think those fears are unsubstantiated, but I'm very happy to take it to the list.
Okay, thank you. Okay, we're running short time, as I already said. Next presentation is Johan. And we have reserved 25 minutes and we have less than 25 minutes, but yeah, okay.
Yeah, and don't forget, we can take all of these to the mailing list. But
Next slide, please. So this is about work that Peter and I did following the last IETF, the one in London. And the starting point for this, the problem statement, so to speak, is that scanning is costly. And we have a growing number of scanning things in DNS now. We have CDS scanning and we have CSync scanning, and we have things that are slowing down convergence of the DNS hierarchy at a rather high cost, or in some cases extremely high cost. Then we also have, because both Peter and I work on the multi-signer things, we have another case where this is a bit of a problem with scanning, because we have in the multi-signer case a need to keep keys in sync across multiple signers. And if they are not in sync, we open up for broken signature chain, which will cause problems. So that's another point where scanning comes into play, and perhaps we really need very, very frequent scanning, which is obviously not a good design choice. Next slide, please. So then we got to think, is there any prior art here? Anything we could look for guidance? And obviously there is. We have notifies. We have RFC 1996, which says that instead of having secondaries basically scan, as in repeatedly poll, the primary for zone updates, instead the primary sends a notification to the secondary and saying, now is a good time to actually check for updates because I happen to know that there have been updates. And we all know that we actually use Notify for basically every zone on the internet today, and it works fine. So then we thought, okay, do we need to actually update RFC 1996 for this to make it work also in our case? Next slide, please. And it turns out that we don't, because RFC 1996 already allows for other RR types than SOA to be sent. I didn't know that before. I learned that. So we don't have to update 1996. It's fine as it is. It's just that today we only use it for notify with an SOA in it because we haven't found a use case for any other thing. But now we do have those use cases. So what we are suggesting is notify CDS to inform the parent that the child has published a new CDS, and notify CSync to inform the parent that the child has published a new CSync. Next slide, please. But where should we send them? Well, because this is sort of vertical notification rather than the traditional notify, which is sort of sideways from the primary to the secondary. We need to figure out where to send it. And we obviously know where the parent is. So let's ask the parent. So our proposal is to send the notification to a destination announced by the parent. Our suggestion, we started working with this with other alternatives. We tried to fit this into an SRV record, etc., but we couldn't really get a clean fit. So the current proposal is to use a new RR type for this that we propose we call notify. And the notify RR type would be the publication point of where we want to have the notification sent, as you can see in the example there. We also add a scheme parameter. The reason why we add a scheme parameter is because of concerns that perhaps there may be other needs for how to locate where to send the notification, in spite of us only defining one such mechanism. Next slide, please. And then we get to the slightly more complicated case, which is what we need for multi-signer. In the multi-signer case, we have more than one signer. And when you have more than one signer that each generates its own keys, we need to basically cross-feed the keys between the signers, the public keys that is, so that each signer signs a complete RR set with all the keys, so that regardless of where from you got the keys, they will be signed by the chain that you're following. But signers today, as in authoritative name servers or other types of signers, they roll their keys automatically. And they basically don't inform anyone because, for instance, rolling your zone signing keys is considered to be a completely internal operation. No need to inform anyone in advance. And that's sort of true if you're the only signer, but it immediately breaks down if you're not. And in the multi-signer case, you're not. So we need to have information about keys rolling so that we can make sure that they are immediately synchronized across the multiple signers. So we have a similar situation as we have with the CDS and the CSync scanning. We need to track these changes of the DNS key RR sets in each signer, and that's costly. So we need some sort of notification. Next slide. And because we're short of time, let's basically just skip some of the multi-signer complexity here. We we have the multi-signer thing, talk to all the signers synchronizing stuff. Next slide. Synchronizing more stuff. Next slide. Done. Next slide. Nice pictures. You can look at them afterwards. And if we don't keep this in sync, bad things happen. Next slide. Next slide. So here we have the proposal to add a third new type of notification, which is the notified DNS key. And the problem with the notified DNS key is obviously that, well, we need it, but it shouldn't be sent to the parent because the parent basically doesn't care. It should be sent so that it's available to other signers or to the infrastructure that is keeping signing in sync in a multi-signer context. Next slide, please. And here we have the result with the red arrows being the notifications. So assuming that the signers actually send notifications to a multi-signer controller, that's the music thing at the bottom, so that the music controller is aware when these happen, it can do the blue things, which is updating the DNS key RR sets in both signers so they are kept in sync, which is actually what we want to achieve. And it can also take care of sending CDS and C-sync notifications to the parent in case the signers are not able to do that themselves because they haven't sprouted that capability yet. And all of this works really, really nicely. Next slide. And then we get to the hairy question of where should we send the DNS key notifications. And we cannot send them to the parent because the parent doesn't care. It's obviously the child that cares. And our proposal here is to use the same mechanism as we use in the CDS and C-sync case and look it up in the child zone instead. The same new RR type, the notify RR type, and again, look for where to send the notification. We have the same format, the same scheme parameter. We only use the first scheme equals 1 here in what we define as the most simple mechanism, but we leave it open for the future to define possible other mechanisms should such mechanisms become needed. Next slide, please. So what about the RRR model? Well, in the RRR model, in most cases, there is no issue. I mean, for instance, many CCTLDs and other TLDs, they already do this type of scanning and they do update the parent zone based on what they find, as they find a CDS, for instance. And then they inform the registrar through EPP notifications somehow, and the registrar keeps in track. Should that not be possible in some context? I don't know, but of course that's theoretically possible. We could have some sort of notification forwarding, either through DNS or directly in EPP or whatever. I basically don't care. I'm just making the observation that it could be done somehow. So to me, the most important thing is to not consider the RRR model as a showstopper, because if it was a showstopper, then, well, we would have lots of problems with also with the CDS and C-sync scanning. Next slide, please. So what about the security model? Well, I think one of the best things of RFC 1996 is that it doesn't impact security, because it doesn't say anything of whether to trust the hint that the notification is. It only says it could be a good thing doing whatever verifications we intend to do regardless about now. So we keep the security model of whatever the scanner is doing. We're just telling the scanner, do it now rather than tomorrow. And thereby we improve service to the client and we improve coherence in the system. So the security model is really not a difficult issue here. The last point I want to make is that it's important to be aware that the difference between RFC 1996 notifications, what I call Notify SOA, is that Notify SOA is something that is sent in the DNS protocol between name servers. This is still DNS protocol, but it's not sent between name servers. It's sent to a service. The recipient of these notifications is typically some sort of scanner service or similar, or in the multi-signer case, it's a multi-signer controller thing. It's not a name server. Just to point that out. Next slide, please. And that's it. We propose a bunch of new notifications. We're not changing the protocol because RFC 1996 already allows this. We suggest that for the location mechanism of how to find where to send the notifications, we add a new RR type. There could be other alternatives, but this is our proposal. And that would mean clearly a protocol change, while the added types of notifications by itself is not a protocol change. And we would very much like to see this adopted. Questions? Victor?
So, yeah, we only have 10 minutes for the next presentation, so really apologies. So if it's a very, very short remark, fine, but I rather have the follow-up discussions on the mailing list, because otherwise the last presenter will have no time.
Very short remark. Once it's a service, we should consider whether the transport is still UDP or something else.
True.
Thank you. Thank you very much. And again, apologies for the limited time. And thank you for being very competent and short. Excellent, thanks. Last presenter is remote.
Okay, can you hear me okay?
Yes, excellent, thanks.
So this is about a method for a name service to signal programs outside of the name service software, and which are not necessarily involved with the DNS protocol, about conditions that can arise within the name server. And these signals can be used to invoke actions in areas that help provide a DNS service, such as routing. Next slide, please. And this initiative emerged from a real-world use case. So SIDN serves the .nl zone and a few other zones, and they do this in a anycasted fashion, and they manage their anycast network in a highly dynamic and automated way, which has been presented at DNS.org 39 in Belgrade. They can add and remove anycast nodes dynamically. And when an anycast node is added, it behaves as follows. So the prefix in which the IP address resides that serves the zones isn't announced yet from that new location. But first, it's the name server loads all the zones, and when it has all the zones loaded, it signals outside of the name server software, and that triggers the route or the prefix announcement to be made. Next slide, please. And for this, they rely on a feature in NotDNS, which is called dbus event. And dbus is a technique for inter-process communication. It has also a publish-subscribe mechanism. So the not name server can signal it is started and all zones are ready to serve on a dbus channel to which scripts can subscribe and take action. So dbus is not an IETF standard. It is specified under desktop.org, which is a collaborative zone for standards and specifications and not a formal standards organization. Because of SIDNs relying on this feature, they now run on not DNS only. in their network. And so for robustness, they would rather run a more diversity of software on their nodes because we all have different bugs. Next slide, please. So for this, we would like to standardize this mechanism properly, and hence this draft. But to do it correctly, we like to inventory the requirements first. So what other conditions are interesting to signal out of the name server? And what associated action could I have? And what publish-subscribe mechanisms would suit that best? So some conditions that we thought of already is, of course, the first one, are all zones loaded and ready? For which you can start a BGP announcement. Or is a zone perhaps about to expire? Because then you want to remove the prefix announcement. Same for DNSSEC signatures if they expire. We could also imagine that if the query weight is exceeding a certain threshold, you would like to, or one could want to demotivate the reachability of the Anycast node by lengthening the BGP path, or the other way around, shorten it so it will absorb a denial of service attack. And may also be actions which are not related to routing, such as if a zone is loaded, updated, trigger a external validator to validate the zone. Next slide, please. Next slide. Thank you. So there are some existing signaling mechanisms, notify, but that stays within the DNS, is not very suitable for this use case. Sending queries to an extended DNS errors monitoring agent, that's very new, not yet RC. I don't think it has a lot of implementation yet. There's the drunk name server that does it, of course. But, it's also more focused towards logging of signals. Yeah, to be fair, dbus may not be a bad option, right? So far, all the actions that we have inventorized have been local. dbus has local or local to the system security and authentication mechanisms, which are standardized within the IETF. It has very good support on Linux, and it's supported on BSD. And it's easy to use. And for reference, I quote this Python script, which listens to dbus and performs actions from the not DNS repository. Next slide, please. So we discussed this in November after the DNS.org presentation of SIDN's Anycast network. And they would like to have it standardized so they can use more software in the same fashion. And I informed the different open source name server vendors, and some recognized the operator interest for this, and I also think it's worth standardizing. So next to Mark Groeneweg and Stefan Ubbink from SIDN to represent the operator, we managed to recruit a representation from the name server software as co-authors. Katty Almond for IC, who has a lot of exposure to operators, Peter van Dijk for Power DNS, and Daniel Salzman for Not DNS, who was the one who came up with the dbus idea for Not DNS in the first place. And yeah, by presenting this here, I would like to get feedback from you, to get statements of interest, if you're interested in this, in particular from Anycast operators. And also, I think it will be good for to complete the requirements to also inventorize more conditions and actions, associated actions. So this is the presentation. And there's one more minute left, I think.
Yes. One more minute, and then we'll have to wrap up. Thanks.
Yeah.
Hi, Willem, this is Liman. Please do
Hi,
this.
Liman.
Very good. Thank you.
Okay, that's our agenda for the day, right on time. Thanks everybody for being here, and for the folks that got up way early or way late out there in Radio Land to join us remotely. Please keep in mind that all of the drafts we discussed, and if we can continue discussions on the mailing list, and it sounds like the chairs have a couple of calls for adoption to do. So thanks everyone. Did you have anything to add?
Thank you all, and hope to see you with the next IETF in San Francisco. Thanks. Bye.
We are adjourned.
Sorry. Oh,